I want to go back now to comparing this IARC report with the California report on this adult leukemia and adult brain cancer, and also a report by CIFAS, which agrees with California, because this IARC report has propagated through to this senior report. We were intrigued as to why there was this difference in assessing essentially the same data in 2002. The next slide, I need to take you through it if I may, is just to say how epidemiology works. Epidemiology studies cancer rates near magnetic field sources and compares that with cancer rates away from magnetic field sources. And depending on what you find, you get a risk ratio. If the rate of cancer near the source is similar to away from the source, then okay, the same risk ratio is 1. If the cancer rates near the source are doubled, the risk ratio is 2. But that's not the end of the story. Because in practice, these studies will be based on small numbers of cases, so there are statistical fluctuations in those numbers, and so the whole thing has errors in it, and the whole thing could be just due to chance. So we have to calculate something called the p-value, which is the probability that the observation was an accident, was a fluke. And statisticians use this criterion of 1 in 20. The probability of the whole thing being a fluke has to be 1 in 20. That's a p-value of 0.05, 5 in 100, before this is said to be statistically significant. Now, 1 in 20 is not foolproof. As you know, 1 in 20 odds horses, including Irish horses, sometimes win races. So it's not foolproof. But if you put a lot of studies together, you can get rather better p-values, 1 in 1,000, maybe even more than that.